Hocus Pocus
Everybody focus.
for our workshop time today. We're going to review some problem types because I really want to get some word problem practice. That's what this quiz was all about. That way everybody gets a quick reminder on our problem types, and then we'll get a chance for our quizzes. Remember, whenever you get your quiz back, you get to see what did you miss, and then I'll show you your marks, and you can make your corrections. If you got like an 80 or something, and you see that you missed things, is it smart to just look at it and turn it back in?
No.
Is it smart to look at it and think, man, what did I do wrong? What can I fix on this? And then do your work and turn it in?
Yeah.
Yeah, take the time to actually correct it, because you can bump that score all the way up to 100% on your quizzes. Tests are a little different. We can only go up to 80, but our quizzes, you can get all the way back up to 100. You have that chance, so take it. Capiche? We're going to go ahead and start looking at these problem types, and I think I might have to zoom them in a little bit on my computer. All right, friends, you should have already seen this at home, but my friends that are here, I want to go over some types of story problems. Clearly this is old because they're all about Miss Ron Hoppy, but you guys know that's still me, right?
Mm-hmm. Yeah.
Who can tell me about this very first type of math drawing on the left? Emerson.
That's a math mount.
That's a math mountain. When we have an addend and another addend, which I don't know why I say that's silly, and a sum or a total, that's a math mountain. So listen for some keywords, friends, in this problem. Because in the middle I've got a story problem, and then on the right side I show how you would actually draw it for this problem. Does anybody want to read that story problem? Olivia, loud and proud.
This round mountain has 10 white balloons and 20 red balloons for the game. How many balloons does she have in all?
Bingo. Should I change this to Mrs. Scholes?
Yeah.
That would make more sense, huh?
Mrs.
How many balloons does she have in all? Who writes some keywords that told you or gave you a heads up like, hey, we're going to be adding, we need a math mountain? Miss Macy.
There's 10 balloons.
Say that again.
That there's 10 white balloons and 20 red balloons.
Ooh, so she's saying there's white balloons and red balloons. The word and almost always means add. What does and almost always mean?
Add.
So that's a good keyword. She's noticed that there's two types, white and red, and that and word tells me to add. There's another word that asks, there's a phrase actually, it's two words together that tell me I'm trying to find a total, that I'm putting things together. That's an ask. What do you think, Madison? Do you see some words towards the end of that problem that are two words that tell me I'm putting them together to find a total? What words are they? How many does she have in all? In all. Jaden, Addison, those go in box 2. That way they're all turned in. So there's my math mountain when I'm adding. We're taking two numbers. We said, hey, there's 10 white balloons and 20 red balloons. To figure out how many there are in all, we can put them in a math mountain to find our sum. Capiche? Here's the next one. Sometimes the math mountains are used for subtraction. So this was a put together math mountain. This one's an example of a take apart. Somebody want to read this one? Let's change it to Mrs. Scholes really quick. Ellie, loud and proud.
Mrs. Scholes has 30 balloons at the game. 10 of the balloons flew away. How many balloons does she have left?
Good. I knew a total. I started off with 30, and then 10 of them went away. Do you remember talking tiny tumblers way back in the day?
Yeah.
So 10 tiny tumblers fell down to this side of the math mountain, and they want to know how many tiny tumblers were left to fall to this side. Who remembers a fancy word for the answer to a subtraction problem. Keegan?
So, when you have one of the numbers, you have 30. You subtract 10. Then all you have to do is, 10 plus what equals 30.
Ooh, yeah, exactly. I could add this amount to get to 30. I find when I'm putting numbers together, I find the sum for an addition problem. What am I finding for a division problem? It starts with division for a subtraction problem. Starts with a D. You're finding the, Emerson?
The
River?
Different.
The difference. We're finding the difference for a subtraction problem. I'm gonna pause really quick because I have some friends who are using tools that we don't need right now. So take care of the tools because we need to get more points on the board for you guys, not for me. Let's be good listeners here. Okay? Next, problem type?
I knew it. Problem type. Problem type. Problem type.
These are comparison bars. Finger on your nose if you have read or used comparison bars before. Aha, so we're gonna review. Sometimes, and there's a little explanation here, whenever we're using comparison bars, we put whatever number is the biggest on top because that bar is bigger, right? And then the smaller bar is for the smaller number. And the circle always shows the difference. What does it show?
different.
So it's when we're comparing two things, okay? For example, I see two names, I see two numbers, and I've heard words like more than or less than. So let's go ahead and read this one all together. Shannon read 200 pages in her book. Joe read 75 more pages than Shannon. There's the more than. They're not right together, but it's more pages than. Let's go ahead and read the question. How many pages did Joe read? Well, friends, we have to think first. Who read more, Shannon or Joe? It says Joe read 75 more than Shannon. So who read more?
So it's 275.
Oh, I'm looking for GPAs because we're in third grade. Olivia. Joe read more. So usually you would put a J here, right? To remember that, hey, Joe read more, so he goes on top. Shannon read less, so an S could go here for Shannon. I plugged in, Shannon read 200 pages, so we put it right here. Joe read 75 more. This more than, less than, or the difference goes in here. What would I do with these two numbers to find my total? Or to find how many Joe read? Hendricks? We would add them up. In fact, you can picture an invisible math mountain in here. Those bottom two are always going to smash together to equal the amount on top. So sometimes your problems will use comparison bars. There's a couple more. Here's one we've been using. What are they?
Equal groups.
Mrs. Swamp bought 4 boxes of markers. Oh look, 4 groups. There are 8 markers in each box. 8. How many markers did Mrs. Swamp buy? Now here's the reminder. Because there is an equal amount in each group, they're equal groups. So I can use repeated additions. 8 plus 8 plus 8 plus 8. Or, because you guys have been doing these for a while, we know that we can say 4 groups of 8 is the multiplication problem. 4, guys, pass.
Yes.
How would you write 4 groups of 8 as a multiplication problem? Brielle. Say that again. If I say 4 groups of 8, I would write it as 4 Okay, we got cut off a little bit, but Brielle was totally right. If we had 4 groups of 8, instead of doing my repeated additions, the multiplication for 4 groups of 8 would be
4 times 8.
bingo. We could solve that. That would be a total of 32. Now, we drew this up here because we know the total can go on top. Do you have to draw these legs in the box for equal groups?
Yes.
Do you have to?
No.
Not for equal groups. You don't need to. But you do need those for equal shares. Equal shares we use in division problems. What do we use them for?
Division.
So if we know the total and we're splitting it up or we're shrinking it down, that's when we use our equal shares. Who would like to read this problem? Gunner, loud and proud.
We know, is it that bottom one?
Right here.
Nick. Okay, Nick bought 4 boxes of markers. There were 32 markers in all. How many markers were there in each box?
Very good. So he bought 4 boxes. We're showing that with our 4 groups. He started with a total of 32 on top. Who can tell me how you would solve this problem? Braylon.
You could either put like dots in there until you get to 32.
Good. Like 1, 2, 3, 4, 5, 6, 7, 8. Yes.
Or you can like
Count by what?
twos.
Oh, I can't count by 2s because there's not. Right now, there's not 2 groups. There's 4 groups.
So you could count by 4.
Good. Let's practice that. Count by 4s with me. 4, 8, 12, 16, 20, 24, 28, 36. You got to it. How many times did we count by 4s? 8. Which means you would put 8 in each group. Right? Very good. Or, mathematicians, because you're getting so good at this, check it out. Some of you are really going to like this. As long as you have this part that you show me you understand with equal shares, if you've got your division facts memorized and you know that 32 divided by 4 is 8, you don't have to plug in the picture. You would just need to write your equation. How's that sound?
Nice.
Well, like maybe we want to start memorizing our facts, right? Okay, last one.
Last one.
Area models.
Area.
Oh, you know what? Sorry, that's not the last one. There's also a race. The area models. I have a box that I know the area. Oh, this one actually I did not know the area. But if your kitchen wall is 8 feet by 5 feet and you want to find the area of the wall, area, the
Space inside for space inside we multiply.
You also might see this with boxes. So let's say, let's see here. I'm going to put it right here. See if this works for us. If I put in a 4 by 4 shape here, and these were all, is it okay if they're rectangles or do they have to be squares? They have to be squares. So, if they're squares, that means they've got a fancy label of square units, and you could totally find the area of this, right? I better put in an arrow so people know that that's what I'm talking about. What do you think? Alright, let's get a little arrow here. One of these days I'm going to have to teach you guys how to do these things. Does that sound good?
Yeah.
Yes.
For real?
Yeah.
For reals?
Yes.
Yeah. Well, you can see how I just did that one, and I'm going to move my table to right here. So you can also find, oops, I didn't want to move that guy. So you can also find the area with those models. Yes, ma'am.
Last night I was looking and I found Mary had a little layout that was done in
Oh, really?
Yeah.
Was it on the chart that we did, or was it another thing you found? Was it on like the songs chart that we were practicing yesterday or a different one? Cool. Focus, focus. The last problem type, Miss Jade, is what?
Hooray!
Arrays, and that's when we have rows and columns. Third grade.
Yeah.
I want to pass back your quizzes. You all finish your quizzes. Now, here's the thing. Some of you got a 95. Do you know what that means?
Yeah.
If you got a 95, all you forgot to do was your labels. Or you put the wrong labels. And so I want you always going back to the end of your problem and looking for that. How many? Because the blue is your label, right? The other thing, class. If you have no label, I just left a blank line for you to see that you forgot your label. If your label was wrong, like let's say this says how many pictures, and you said the answer was 21 yearbooks, then I would have underlined yearbooks so you know, oops, I just wrote down the wrong label. Capiche? Also, what if you did the right equation? Like for this one, you said 3 times 7 equals 35. Well, if I see this problem, the way that I'm going to grade that is I'll mark and I'll be like, hey, heads up for problem number 4 here. You missed it. So I would circle it to know that you missed it. But I'm going to let you know what you got wrong. I would actually say, okay, this is the right equation, so I'm not going to put any marks there, but I'll give you a heads up that you just multiplied wrong. You just need to double check your count bys and fix that up, and then don't forget a label. So you know what part you need to fix. Capiche? All right, I'm going to pass them back. Good luck with your fixes.